Hello, so we're outside, let's go and have a look at the observatory. So this is the observatory, it's a pulsar observatory, it's 2.1 metre, fiberglass dome, has a shutter aperture. Let's go and take a look inside. Okay, so inside the dome, let's take a little look at some of the equipment that we've got inside. So first of all, the mount is an EQ6, Skywatcher EQ6 Pro. The mount's about 12 years old. It's a fairly go-to setup for amateur astronomers. It's showing a bit of age. Because it's based in an observatory, you can see there's quite a bit of rust has appeared, but that doesn't really affect its operation at all. On the mount we've got twin William Optics refractors. So the one on the top is a 90mm doublet, it's a Megres 90, and the main imaging scope is a FLT 110 triplet. It's a very nice setup. It's particularly well suited for this particular observatory because of the way they're mounted on top of each other. They're piggybacked, which helps with the width of the aperture. So I chose this particular design because we have a lot of ambient light pollution in the very near neighbourhood. So there's a car park just here, and there's a light in the car park which is always on at night, so that helps to prevent any light pollution from that, and also if the moon is around it helps to shield, and because of the narrow aperture, the positioning of the scopes means I get as much imaging time as possible without having to move the top of the dome around. Obviously this rotates in order to facilitate imaging. Now that's not automated. The reason that's not automated, there's a couple of reasons. First of all, it's extremely expensive. Secondly, this is an early model of pulsar observatories, domes, and it is not designed for use with the kit that they currently produce. So it would need quite a lot of customizing in order for that to work. The cameras, the main imaging scope has well, first of all, there's a filter wheel there. So it's a TrueTech super slim wheel with 6 filters and 1 dark filter position. So in terms of filters that are inside the wheel, I have a full astronomic setup. So there's an LRGB, hydrogen alpha, and oxygen 3 filters in the wheel. So underneath the filter wheel, this is a dew heater that I use just to keep moisture off the glass in front of the sensor. It's a SXVH9 mono, and on the guide scope we have got a Starlight Lodestar, the later model. So there's the Starlight Lodestar X2. So I should just say that the field of view that I get with my main imaging setup through the FLT 110 is 30 by 40 arc minutes, which is about the size of the full moon. So the full moon's 30 by 30. So it's about ½ degree by ½ degree. So in terms of power, I have some lights in here which I use when I'm first setting up. There's a red and a white light. I have a power board down here, and that's wired into the garage on a separate circuit. Let's talk a bit about computing. This was the computer that I used to use to control everything. It's on a very old IBM ThinkPad. It's quite a capable machine. Reasons for upgrading, changing things. I didn't like leaving the computer out here, which was often the case. Sometimes it would get quite wet with the moisture and condensation, so I've recently upgraded or changed my setup. So this is the new computer that I'm using, which is a Raspberry Pi. So here's the case. The case is much bigger than the actual computer actually, and the reason I chose this particular case, there's no fan inside, so there's heat sinks which contact this aluminium surface and dissipate the heat, so it's a completely passive cooling setup. So you can just see the computer, the main board is inside there. It only actually takes up about this much of the case, and then there's an access flap here which you can remove, it's magnetic. That's in case you want to add a breakout board to enable the computer to perform other functions. Perhaps you would add a camera, so you would add an extra board there with cabling to support the camera. So as you can see, we have Ethernet. The Ethernet goes directly into the laptop, and the laptop is solely used as a screen, so I can focus primarily and select targets, and also monitor what the system's doing. So that is just used as a screen for the Pi, and that's over Ethernet, so there's no latency involved. Then we have an additional Wi-Fi dongle to improve the range. I'm not quite sure how much improvement that provides, but I was struggling with the built-in Wi-Fi, so I added that on. The Lodestar is going directly into a USB 3, and then the other connections are power. And I have a USB hub here, and that's handling all of the other USB connections. So we've got both the cameras, the filter wheel and the mount going in here, and then that goes directly into the Pi. And that's the basic setup. So it's fairly neat and simple. The main issue is the number of USB connections which have to be handled, and there were some issues with compatibility with the Lodestar, so I broke that one out and put it directly into the Pi. But apart from that, this is the setup that I'm using at the moment. A little bit more on the specifications of the Raspberry Pi that's inside the case. So the machine itself is a Pi 4 Model B. I think that's the latest one that's still available. The processor is a 1.5 gigahertz quad-core CPU, and this model is a 4 gigabyte RAM model. You can get it in 2, 4 or 8 versions. It supports dual HDMI output at 4K. It has gigabit Ethernet, Bluetooth, Wi-Fi, 2 USB 3 sockets and 2 USB 2 sockets. It's £54 at the moment from the Pi Hut, and there'll be links for that. I purchased mine from Amazon, paid £90. It came with a different case which I've since upgraded. So the case, actually this case was about £30. It's a little bit specialised. It's called an Argon 1 if you're interested. The kit that I bought comes with a 32 gigabyte SD card even, which is where all of the software is installed, and I think that's underneath here. I can't quite get a view of that, but the SD card contains all of the software including the operating system, and of course the power supply and cables and stuff like that come with the kit that I bought, and I thoroughly recommend it. It's a great tool for learning programming as well as little projects that you might want to try to set up and implement around your house, a garden even. So in terms of operation, what I tend to do, and you'll see a bit later on in the talk, I will come out in the night, I will set everything up using the laptop as a screen, and that's wired into the Pi, as I mentioned, and then I'll go back into the house and I'll monitor the operation of the imaging run over Wi-Fi. The plan is to eventually wire in the Ethernet to the house, but we haven't quite got there yet. And that's the basic setup. So while I'm out here, I'll give you a quick look at the software. So what I'm doing now, I've just fired up the laptop, and the laptop is set up to start up a browser on a page which links to the VNC, via VNC rather, to the Pi. So this is the home screen of the Raspberry Pi that we're looking at now. And this application is the, let me just get that reflection. So this application is the Planetarium software, which comes bundled with the software installation which I set it up with. So we'll talk about that in a while. It's called Astroberry, and it's basically a suite of software applications which work together to provide a full solution for a home observatory. So this is the Planetarium software. It contains everything that you would expect within a piece of Planetarium software. So it has a database of objects which you can search. Obviously it's a fully zoomable interface. It also has this rather neat ability to load images from sky surveys so that you can see around objects, and you can see in particular parts of objects that you're interested in imaging. So this helps a great deal when you're setting up an imaging run, so you can focus on a particular part of an object and without having to move the scope around too much and take images to find out where you are. It also has a very interesting, or a very useful pointing. Let's just start it up. So we have to connect to the scope in order to see more of the features. So we're now connected, and it has an excellent alignment feature which enables you to accurately align on any part of the sky, and I'll do some screen captures of this later on in the talk. But basically you have different aspects. So you have a camera tab which enables you to interact with the camera and filters. You have a focusing tab which actually I don't use, so I did try to fit an autofocuser to my main scope. It's actually this one down here. So I did try to fit this autofocuser. It didn't go too well. Actually, it ended up breaking my micro focus assembly, so I'm not using that. Not sure if I did something wrong, but I just don't think that this particular scope is well suited to autofocusing, so we abandoned that project. But there is a facility for autofocusing, and you've got all of the settings here. And then there's guiding built in, so it has an inbuilt guiding feature, and obviously make use of that on every imaging run. It has a scheduling ability where you can schedule targets, and then you can continue them over multiple nights of imaging. And this is just a summary screen where you can see latest images and guiding all in one place, so this is a good overview screen. But we'll do some screenshots and go into those in more depth a bit later. Right, that's enough from me out here. Let's go back into the house.